functions. A quadratic function is a function described by a equation of the form f of x is equal to ax squared plus bx plus c, where a is not equal to 0. The domain of quadratic function is the set of real numbers. So the graph of quadratic function is called parabola. Parabola may open upward or downward and vary in width or steepness. As you can see in this image, this one opens downward and this two opens upward. And this one is wider than this one, and this one is narrower than this. Later on, you will find out what is the reason behind the differences among the parabolas. You can see a line, the green, red, and yellow lines here. So these lines are called axis of symmetry. This axis of symmetry is the line that divides a parabola into two parts that are mirror images, meaning a parabola is always symmetrical. And the point where the axis of symmetry and parabola met is called the vertex. The axis of symmetry of the graph of a quadratic function is always a vertical line defined by the x-coordinate of the vertex. Since the axis of symmetry is always a vertical line, then it only opens either upward or downward and will never be open to the right or to the left. Here is a table that will help you to determine the direction of opening and the vertex of a certain function. For example, y is equal to ax squared. For example, we have y is equal to 2x squared. So the vertex of 2x squared is at the origin or at 0, 0, and it will open upward. But if it is negative 2x squared, then it will open downward, but the vertex is also at the origin. But another thing is that as long as the absolute value of a increases, the graph becomes narrower. For example, we have 2x squared. The graph of 2x squared is narrower than y is equal to x squared. Here are other examples of quadratic functions. You can see that this is negative, so it opens downward, and it is positive, so it opened upward. Here is a sample problem that I have prepared for you to easily understand the quadratic function and how to solve quadratic function problems. The suspension cables between the two towers of a hanging bridge form a parabola that can be modeled by the graph of y is equal to 0.05x squared plus 1, where x and y are measured in meters. What is the height of the cable above the roadway at its lowest point? So let's analyze the problem. We have here suspension cables that form a parabola with a graph of y is equal to 0.05x squared plus 1. So we are going to find the distance between the lowest point, which is the vertex of the parabola, from the roadway. So the first thing that we're gonna do is to find the vertex of the parabola so we can determine the x-coordinate of the vertex. So the given equation is y is equal to 0.05x squared plus 1, and a while ago I showed you this table, and it follows this letter E, which is ax squared plus bx plus c, and we assume that b is equal to 0 since it is not shown in this given equation. So if we get the values of a is equal to 0.05, b is equal to 0, and c is equal to 1. And as shown in this table, to find the x-coordinate of a given equation, you have to use this x is equal to negative b over 2a, and we substitute the values of b and a. So negative 0 over 2 times 0.05, so it will be 0 over 1, and we'll come up with 0. After we get the value of x, we will find the value of y by substituting the value of x that we get on the given equation. So y is equal to 0.05 times 0 squared plus 1 So y is equal to 0 plus 1 and y is equal to 1. So the cable is 1 meter above the roadway at its lowest point. I hope you learned something from this video. Thank you for watching.